A sheet of glowing hot glass slowly moves through an automotive factory. Within minutes, it will become the side window of an ordinary car. At first glance, everything looks completely normal. Clear glass, smooth surface, a black border around the edges. But right now, engineers are adding a feature that billions of people see every day, yet almost nobody understands. Those tiny black dots around the edges of car windows. Most drivers assume they're just decorative, a simple design element. But if those dots suddenly disappeared, modern cars would face serious problems long before they ever reached the road. In fact, the entire manufacturing process would be affected. Today, we're uncovering the surprising reason these mysterious dots exist and why engineers have relied on them for decades. To understand the dots, we need to go back to the 1950s. Back then, car windows were held in place using thick rubber seals. The system was simple and inexpensive. A large rubber gasket wrapped around the glass and fit into a metal frame. The technology worked for decades, but it had a major flaw. Rubber ages, it cracks, it shrinks, it lets water inside. At highway speeds, air would whistle through tiny gaps, creating the annoying wind noise that owners of older vehicles know all too well. Even worse, those rubber seals contributed almost nothing to the structural strength of the car. They simply held the glass in place. By the late 1960s, engineers began searching for a better solution. The breakthrough came when manufacturers started bonding glass directly to the vehicle using polyurethane adhesive. By the 1980s, this became the industry standard. The benefits were enormous. The windshield became part of the vehicle's structure. Body rigidity increased significantly. Wind noise decreased. Cabins became quieter. And in a rollover accident, bonded glass helped support the roof and keep passengers protected. It was one of the most important safety improvements in modern automotive history. But a new problem quickly emerged. The powerful adhesive holding the glass in place had an unexpected weakness. Sunlight. Polyurethane adhesive doesn't like ultraviolet radiation. Over time, sunlight passing through the glass slowly breaks down the chemical structure of the adhesive. The glue becomes brittle. It develops microscopic cracks. Eventually, its bonding strength begins to deteriorate. In extreme cases, the windshield could lose part of its structural integrity. Engineers needed a solution. At first, they experimented with chemical stabilizers. Then, they modified adhesive formulas. Nothing worked well enough. Finally, they discovered a surprisingly simple answer: hide the adhesive from sunlight. That decision led to the creation of the black ceramic border that surrounds modern automotive glass. But solving one problem unexpectedly created another. The black border isn't ordinary paint. It's made from a special ceramic material called frit. During manufacturing, the frit is printed onto the glass and permanently fused into the surface during the tempering process. Unlike paint, it can never peel, fade, or wash away. The solution worked perfectly for protecting the adhesive. However, engineers soon noticed something alarming. The glass was cracking during production. The fractures always appeared near the edge of the black border. Nobody could understand why. The answer came from physics. Before automotive glass can be installed, it must be tempered. The glass is heated until it becomes soft and then rapidly cooled. This process creates internal stresses that make the glass much stronger and safer. But the black ceramic border absorbs heat much faster than clear glass. Inside the tempering furnace, the black sections became hotter than the surrounding transparent areas. When the glass cooled rapidly, large temperature differences created dangerous stress concentrations. Cracks began forming along the border. Manufacturers faced huge losses due to defective glass. The industry needed another solution. And that's when the famous black dots appeared. The dots aren't decoration. They're a carefully engineered thermal transition zone. Notice how the dots are larger and closer together near the black border. As they move toward the center of the glass, they gradually become smaller and more spread out. This creates a smooth transition between the hot black border and the cooler transparent glass. Instead of a sudden temperature change, heat is distributed gradually. The result? Far less stress, far fewer cracks, a much stronger finished product. The dots are essentially invisible engineering. Engineers could have chosen squares, or triangles, or any other shape. So why circles? Because circles distribute stress more evenly than almost any other shape. They have no sharp corners where stress can concentrate. This reduces the likelihood of cracking during manufacturing. In other words, the black dots aren't an artistic choice. They're an engineering solution optimized for strength, durability, and production efficiency. The black border and dot pattern serve several additional purposes. First, they hide the adhesive from view. Without them, drivers would see an unattractive bead of glue around the glass. Second, they create a clean visual transition between the glass and the vehicle body. Third, they provide mounting areas for modern technology. Look near your rear-view mirror. You'll often find rain sensors, light sensors, cameras, and driver assistance systems hidden behind the black fritted area. The same technology conceals rear window antennas and heating elements. Even the blue tint found at the top of some windshields uses a similar principle. Despite being over half a century old, the technology continues to evolve. Researchers are experimenting with laser processing systems capable of creating microscopic patterns directly on the glass without using ceramic coatings. Others are developing digital ceramic printing technologies that work much like inkjet printers. These systems could eventually allow manufacturers to create complex designs, smart shading patterns, and customized glass surfaces. Luxury car manufacturers are already testing some of these ideas on concept vehicles. Yet, regardless of how advanced future technology becomes, one principle remains unchanged. The transition between dark and clear glass must remain gradual. Physics still demands it. Those tiny black dots aren't there for decoration. They're protecting the adhesive that holds your windshield in place. They're preventing cracks during manufacturing. They're hiding sensors and electronics. They're improving safety, durability, and appearance all at the same time. It's one of the most effective engineering solutions ever created. Simple, cheap, reliable, and so important that nearly every vehicle on Earth still uses it today. The next time you sit inside a car and notice those tiny black dots around the window, you'll know you're looking at far more than a design feature. You're looking at a small engineering masterpiece hiding in plain sight. If you enjoy educational videos, be sure to like, comment, and subscribe for more.